everyone. Welcome to episode number 614 of this here electronic engineering podcast called Amelia's Weekly Fish Fry, brought to you by eejournal.com and written, produced, and hosted by me, Amelia Dalton. Device security and cryptography take center stage in this week's Fish Fry podcast. My guest is Shahram Mossayebi, founder and CEO at Crypto Quantique. Shahram and I chat about how Shahram's experience in academia and IoT security vulnerabilities encourage the creation of Crypto Quantique, the variety of device and IC security solutions offered by Crypto Quantique, and how their software-based IoT security platform called QuarkLink helps designers ensure compliance with connected device legislation. So, without further ado, please welcome Shahram to Fish Fry. Hi, Shahram. Thank you so much for joining me.
Hi, Amelia. It's great to be with you today. Thank you.
So, Shahram, talk to me about Crypto Quantique and the motivation to create this company.
Sure. So I spent, I guess, over like 7 years studying cryptography and crypto systems at university for my graduate and postgraduate studies. And I did a lot of attacks using future adversarial models such as quantum adversaries, quantum computers, AI, these kind of things, and how they would affect our crypto systems. When I graduated from my PhD, I kind of was looking into real world applications to apply my knowledge and do something more practical rather than just being on the theoretical side of things. And that's when I noticed the IoT attacks and they were getting publicized. Basically, everyone was reading and hearing about them. There were a couple of high profile hacks. Jeep got hacked a couple of times. Then there were some other industrial attacks on IoT devices. And that kind of drew my attention. And I realized this is a big problem in the world and will become even a bigger problem in the world, given that this is almost like 10 years ago, but we were going to a direction of more devices being connected, etc. And what I realized, kind of reading a little bit more into it, that this is, well, partly is a device security problem, but at the core of it, this is a cryptography problem. This is all about device identities and key management and authentication, but at a huge scale. Not only huge scale, but also very fragmented environment because of how these devices are being built from design to manufacturing to use, how the supply chain works, et cetera, et cetera. That was fascinating. And that's pretty much where Crypto Quantique is coming from. So I kind of thought, this is something that I can bring what I've done in academia to real work, to real world, and to make it work on a very hard problem, but real scenario of solving IoT security or device security problems using cryptography or in some sense also quantum technologies.
So, you guys offer a wide variety of device security solutions for developers. So, talk to me about these different solutions.
Exactly. And this is again because of the nature of the beast. So when I'm talking about IoT security or device security, the very first thing that I say is a device. We're talking about hardware. Then the next thing is a piece of software that runs on it and makes it a product, connects it to the internet, applications, etc. When I founded Crypto Quantique, the very kind of first thing that I noticed was pretty much anyone talking in the cybersecurity domain, talking about device security or IoT security at the time, are dismissive of the device security in real meaning. And they are very superficial on how that aspect needs to happen. And they were pretty much talking about software security layers, application security, and things like that, which were important and are important. But what was the missing point is that you can't achieve security on a device if you ignore the hardware or the device security itself. If you're dealing with a piece of hardware, the security starts from that piece of hardware. And that's why we realized we can't go out and claim that we are a device security company without actually addressing the challenges and the problems at the device level first, and then building a bridge from the device security, hardware security aspect to the operating system application and the cloud security. And that's why we have a wide variety of products, because we start from hardware security, device security. We're literally going to the atomic level of a device to create unforgeable unique identities per device that then we use for cryptographic purposes, for confidential computing within the device and authentication, etc. Then we build a different class of products that takes advantage of that hardware security, but these are all software and run cryptography and cryptographic applications to build that bridge between the hardware and other application on the software side and provide a full stack solution, what we used to call it chip to cloud security.
Okay, so you guys also offer device security for IC designers. So let's talk about these solutions as well.
So on the device side, as I explained, we noticed that semiconductor industry, I mean, we're going really deep here. So we're talking about MCUs and MPUs or TPMs. We were talking about the first brain of a device, which are these integrated circuits, ICs, that are actually operating the device. And what we noticed from security point of view, the semiconductor industry were on the right track, and they were providing pieces of hardware ICs that already had, let's say, cryptographic applications. So you at the hardware level, you could run cryptography, and that's great. What we noticed was the key management aspect. All these cryptographic algorithms or applications require different type of secret keys that somehow needed to end up inside the device. And when you're talking about the scale of IoT or devices that are being produced in a very fragmented supply chain, how those keys are generated and ended up inside the device and also found their ways to whomever going to be the end user of this device eventually at some point in time, somewhere in the world, this is huge, huge problem and very, very hard to solve. And that's kind of the problem that we identified. So the type of semiconductor IP, silicon IPs that we created are trying to address those bits. So we didn't try to compete with what was out there, but we try to complement and improve the security to address a specific problem of device identity and key management on the supply chain for these devices. So some of the IPs that we created was one is physical unclonable functions, or PUFs for short. And in our case, we built something from scratch to not only provide the application, the means for identity and key management at the device level, but also provide extra layers of security, such as being secure against side channel attacks and things like this, that the prior products in the market trying to achieve the same thing wouldn't provide. And in order to achieve that, we tapped into quantum technologies. So when we look at the semiconductor industry in silicon level, as you go below 100 nanometers process node, which pretty much most chips are today, you deal with a phenomenon known as quantum tunneling, which, for instance, creates noise and gate leakage on transistors, which usually semiconductor industry doesn't like, and they're trying to kill it to improve the electronic performance. But what we realized was this is a quantum event that could give you some great results when you look at it from a security and cybersecurity point of view and randomness point of view. And that's the phenomena that we are harnessing on usual semiconductor chips to create these unforgeable cryptographic keys that no one will ever know or can find out or doesn't need to be stored inside any memory inside the device, and they are secure against side channel attacks. And then also addresses that huge cybersecurity problem on the supply chain from a key management point of view. So the first IP that we built was this quantum tiling based PUF. And then on top of that, we started adding more IPs. So now, for instance, we have quantum tiling random number generator at the hardware level, which again, another essential IP for security at the hardware level. And we recently joined a Trusted Computing Group, which is the organization, nonprofit organization behind TPMs, Trusted Platform Modules. And as part of that, we are working on building new lightweight security platform for IoT devices, and there are more news coming out soon.
Excellent. Okay, so talk to me about QuarkLink. What is it and how is it used?
Excellent. So I've been going on device security from the beginning that we started speaking, which is absolutely important, and that's the first step. But then the question is, okay, you've done all this great thing at the hardware level. You kind of trying to address all these problems at the hardware level and supply chain level. Now you are a firmware or embedded software developer. You bought some pieces of devices or ICs or MCUs from famous brands in the market. And now you need to write the software, write the firmware for the device, for instance, to turn it to an actual product. How would you actually take advantage of the hardware security that exists in the MCU or ICs that you just bought? And getting those on-device security features to work, these are nuanced. They are not easy. They're complex, time-consuming. There are a lot of low-level code that needs to be written, and a lot of time needs to be rewritten and rewritten as you move from one MCU to another MCU. So there's a lot of building the same wheel again and again and again. But it's an essential part of the job if you want to achieve security properly and really anchor into the device security that exists inside the IC that you just bought. So what we realized was a lot of these features, such as secure boot or secret management at the device level, etc., these are all require key management or public key infrastructure at the software level. So you need other cryptographic keys and secrets to be generated in a different way and be hooked up into your device. And this is not an easy thing to do. So there are a lot of moving parts, low-level code writing, understanding the hardware architecture at a very, very low level. And then you got kind of enterprise, PKI, public key infrastructure type things that you need to deal with. And you're just a software developer, want to write a piece of firmware that does a specific application. That's all you care about. But now you need to deal with all this moving part to get your security sorted. And that takes huge amount of time and resources from the software development team to get security right if they care. And if they care, it costs them a lot of money to do it. So we built this new product called QuarkLink, which essentially is a tool that sits within the CI/CD, the SDLC, the software development lifecycle of these teams, and helps them by providing the low-level code, depending on what sort of hardware they're using, to just integrate it to their existing code base. And that low-level code enables those on-device security features, such as a secure boot and secret management and things like this, but also provides a dashboard, a central place that for a product manager or project manager allows to do that PKI piece, the key management piece that they require from an enterprise point of view in order for these products to hook to the on-device security feature, but also once this product are going out to the end user, they can securely connect to whatever cloud service they're supposed to connect, and also being securely managed, being able to push firmware update over the air securely and do the whole device management later. So that's QuarkLink basically. So it gives you plays in three different areas of an embedded software development life: low-level code to enable on-device security features, tools within the software development environment to help the software developers who don't deal with keys and don't see any secrets, etc., don't deal with the low-level codes, but get all those sensitive, critical features up and running very quickly. And then separately, this PKI behind the scene that enables the whole orchestration during the development, but also during the production and device usage.
So, how does QuarkLink specifically help developers ensure compliance with legislation relating to embedded devices connected to networks, like medical applications, for example?
That's an excellent question because definitely what we have seen in the past, pretty much since 2021 or 2020, we've seen that a lot of regulatory bodies, governments are really pushing hard on devices to have those on-device security features enabled and properly used. And medical device market are leading pretty much ahead of everybody else in the industry from using these on-device security features. And there are FDA regulations, there are NHS regulations here in England, for instance, that are very specific about how security needs to be achieved on devices. So, for instance, they are being very particular about here in the UK or in England, NHS does not buy any device that doesn't have secure boot enabled on the product, or the secret management at the device level is not enabled, or the supplier cannot push a firmware update over the air securely to the devices while they are in use in hospitals, etc. So all these features that I've been talking about from hardware security point of view or from software security point of view that we help our customers achieve with our products are now being specifically mentioned in a very technical terms in all these regulations and new standards that are being enforced soon. And medical devices is one of the leading one that at the device level, the secure boot and then firmware or application update over the air securely are a must. And that's what you can easily achieve using QuarkLink because we just automate your secure boot using the low-level code that we just give you depending on the device, and you just integrate your code base. You don't need to write them from scratch or deal with the complexity of enabling it on your hardware. And then separately, we give you this platform that deals with your PKI, a public key infrastructure, but also deals with your device management, which means if you need to push new firmware update over the air, patch a vulnerability, etc., while the devices are in hospitals, you can absolutely do that.
All right, so where are you guys headed in the future?
We definitely pushing boundaries on, we have been pushing boundaries on device security and IoT security in general. It's great to see in some sense, but what we started to see happening in European Union since 2021, for instance, which now is being shaped as EU Cyber Resilience Act, that is very much enforcing device security, etc. Those type of languages or arguments that now are being put forward by politicians to protect the society and end users from cyber attacks and enforce the suppliers and manufacturers to do product development securely by design. We've been talking about this since 2016. So we've been definitely way ahead of the rest of the ecosystem. We're going to continue pushing them and educate the ecosystem on right now. Post-quantum security is a big topic on, okay, how we're going to move the whole existing infrastructure, device security, etc., to this new era of post-quantum security with all these new graphic algorithms, etc. Crypto agility as part of that is important. How do we separate the cryptographic algorithms that we're using from how we're going to use them within the product so we don't hard code them, the keys and the algorithm itself into the product so it makes it easier and more agile to update them or to transition from one type of algorithm to another type of algorithm, for instance. Generally, on the hardware security, trust is a massive, massive problem. It still is a problem. With all these geopolitical challenges, US, China, trusting the supply chain is a big problem. And that's one of the areas that our research R&D side is pushing. Provide means for the IC vendors or for product manufacturers to be able to attest the validity of the devices, whether they are a genuine device or not, and can trust the device and the pieces of the software or equipment that is on it.
Fantastic. All right, it is time for your off-the-cuff question. So, if you
Okay.
could have one meal right now, it doesn't matter if it's on the other side of the world, you need a passport to get there, what would you have?
All right. Funny enough, I'm defrosting salmon, so I will have salmon for dinner in 1 hour. But recently, I found a lot of comfort in pesto and pasta. Italian will kill me, but with a bit of burrata cheese. So that's kind of my comfort food currently. So I would usually go for that.
I love it. That sounds delicious. Well, I think that's all I have time for today. Thank you so much for joining me.
Thanks for having me, Amelia. Appreciate it.
If you'd like even more information about Crypto Quantique, I've included a bunch of links below the player on this week's fish frying page on eejournal.com and in the description for this week's YouTube episode as well. Hey, have you checked out EE Journal on social media yet? Well, you should. You can find us at facebook.com/EEJournal. If LinkedIn is more your thing, you can follow us on LinkedIn, and we are also on Blue Sky Social and Mastodon too. And we have a YouTube channel, youtube.com/EEJournal. Folks, it is chock full of all kinds of techie videos, including our very popular Chalk Talk webcast series, hosted by me, and our brand new animated series called Libby's Lab. And you can also subscribe to our EE Journal YouTube channel as well. I'm just saying. Also, make sure that you subscribe to this here podcast on Spotify, Podbean, Apple Podcasts, YouTube, or just about any other podcasting platform to listen to some exciting upcoming episodes. Thank you everyone for tuning in. If you know of any cool new technology or heck you just want to chat, shoot me a line at Amelia, that's Amelia, at eejournal.com, or post a comment on our forums on EE Journal. For the week of January 17th, 2025, I'm Amelia Dalton, and you've been fried.